Hi everyone, welcome to Fun Coding Games. This is our 8th webinar series for STEM for Humanity. This is an overview of our webinar today. We're going to do a quick introduction of our presenters today, and each of the presenters, we will be presenting a game that we built or some type of interesting program that we built, and we'll be explaining some of the concepts behind it and doing a quick demo of it. Let's get started. First is introduction. Let's just go around and speakers, say your name, your title, and your grade level. So hi, I'm Emily. I'm president of STEM for Humanity Coalition, and I'm a rising sophomore at Brown University.
Hi, I'm Zach. I'm a board member and I'm a senior at Diamond Bar High School.
Hi, I'm Jay. I'm a co-vice president. I'm a senior at Diamond Bar High School.
Hi, I'm Cecilia. I'm a co-vice president and I'm a senior at Diamond Bar High School.
Hi, I'm Kevin. I'm a rising junior at Troy High School, and I'm the engineering director.
Hi, I'm Isabelle. I'm the director for physics, and I'm a rising junior at Westlake High School.
Hi, I'm Kaden. I'm the secretary now, and I'm a rising senior at Derrick High School.
Hi, my name is Angela, and I'm the Director of Innovation, and I'm also a rising 11th grader at Diamond Bar High School.
Hello, I'm Derrick. I'm the coding director now, and I'm a rising junior at the California Academy of Math and Science.
Great. So these are all the speakers that will be presenting their projects today, and a bit about our organization for those of you in the audience who are new to SFH. So we're STEM for Humanity, and we're a global student organization dedicated to bridging STEM and society. And we want to cultivate creativity and compassion in future leaders, which are those on our student board and our board members. So we're a group of passionate individuals, and we want to use our STEM skills for positive social impact. Okay, so if you're a young innovator eager to make a difference in your community, in your local community, and the global community as well, you can feel free to apply to join our student board. Application is on the website, or you can email us. This is our email, and that is our website. I'm first gonna present a project that I built. So I did use JavaScript, and it was on code.org, so it's a kind of a rudimentary game, but basically I had a bunch of variables like near the start. So these are just variables that they track a bunch of different things. And you have this start screen. So this is a start screen. This is what the user enters with. And then you see that there's this new game button. So you have the option to, once you click on new game, you see these 3 different modes. Once you select new game, you become the host. So whoever, the ID of the player that clicks on new game, that will be stored as the host ID. So there's a variable for that somewhere. Host ID is gonna show up as player 1 host, and then only the person who is the host will be able to click on this ready button. And then whoever receives the invite link, they're gonna have the option to join with the same game IDs. At the game, after you click on new game and then select a mode, there should be a game ID over here, so the other invitee can just copy and paste the game ID, and then they can click on ready. Once both players are ready, there's going to be a countdown timer, and once the countdown timer reaches 0, it's going to go into the game screen. So how the game screen works is basically there's supposed to be a scrambled version of some word, and that scrambled word, you can try to guess what the unscrambled version is. Like, let's say, a word is MAGE. Okay, and then you unscramble it, that is game. So then you type it in, submit, and then you get points. That's how it's supposed to work. And on the end screen, it's supposed to show all of each player's words, like a list of all of their unscrambled words. And then there is a calculation to see who actually won the games. I'll kind of go over the code as well. So this is just all the buttons on the home screen. So a bunch of clicking. So click and then something happens here. So I wrote a start game function. So start game function takes in 2 parameters. So one of them is like the lowest number of letters for that word. If you click on easy mode, then the easy mode words are going to be either 3 or 4 letters long. Same here. So for medium, it's going to be between 5 and 7 letters long. And then what this function does is basically, as soon as you click the button, it creates a new column within the database. There's a database that stores all the different game IDs. If you click on a new game, then a new game ID is generated. That number is randomly selected, and then that number gets stored into the database. So then you can use that game ID later on to run your game. Okay, so that's the joining part. And then this function is just for making sure that a player is joining the same game instance as the host. So it's doing a bunch of checking for the same game ID being inputted. And on the lobby screen, so this is a function that checks that that both the host and the invitee are ready. So actually this button is once player one is ready, they click on the ready button, or sets different columns within the database table so that there's a value being displayed. And if it's corresponding to some value that shows that, that player is ready, then there's going to be a countdown initiated if player two is also ready. Yeah, and I use this timed loop. So time loop is kind of like a countdown timer. There wasn't a way to just import some timer into code.org because it's so fundamental. So I use the time loop and then it's 1,000 milliseconds and then kind of does a countdown sequence until the timer runs out. And then the screen changes to the next screen, which is going to be the game screen. Okay, so game screen is over here. So the same timer goes on and then it keeps on running until the end of the game. As soon as these two ready buttons are done or are clicked, and then the countdown timer starts and then hits 0, that's when this timer for the game also starts. So they're kind of written into the same function. And then for this one, so submit is basically going to do a check for, it's going to take the word that's unscrambled and then try to find the corresponding row within the database of words. So I had a database with a bunch of commonly used words, the most common English words, and I had that in a database. And basically, this function will match your guess and see if it corresponds to any row within the database of words. If it matches to the right one, then that player gets a point. Okay, and then current lobby status, this is checking if both players are ready. Current game status, this will update the points on the screen and show the word as well. So there's an auto-generate feature to get the next word. It's randomly generated from the database. And also if a player gets it right, then there's an update point feature. That's what it is here. Like if it's that player and you're able to find that word in the database, then you add a point to that player. This is for the end screen. Is supposed to display a list of all the words that the player entered and got correct. It's stored in an array, and the array will have words added to it with every correct guess for that player. So that just does some printing and stops the timer. And then this start game function, you have a new game ID, a new player ID, and then that's stored as current game ID and current game ID. And you have a list of randomly generated words. Like before you start the game, there's a bunch of random words being selected out of that database for words. And then you create a new record under the game database table that will be responsible for controlling different aspects of your game, like what are the player inputs and whether they match. So yeah, the rest of it is like generating random features, generating random words. This is a scramble function for randomly scrambling the word. And then reset, it sets everything back to default. That's my game, Unscrambler.
I'm Zach. I'm going to present my game, which is just Wordle. This game is coded in Java in Android Studio. So Android Studio is basically a web development application that allows you to create apps for the Google Play Store on any Android phone. So theoretically, my app could be published right now onto the Google Play Store so that anybody can play it. It uses a database of almost 3,000 five-letter words for you to try to guess. Every single word was specially curated to make sure that it's modern and it fits and is appropriate. And you have 6 tries to guess, just like the regular Wordle. each guess. Green means the letter is in the correct spot, yellow means the letter is in the word but in another spot, and gray means that the letter doesn't exist in the word. So the game ensures your word is a valid word before you allowing you to guess, so you can't just make up gibberish in order to try to beat the system. So the program is, so I used an Android emulator that's provided by Android Studio to run it. So you can see here on the right, I have some screenshots. The game also uses a system to remember previous entries, recording high scores throughout different runs. So in a few years, you can still come back and it will still record your high score, no matter if you logged out and logged back in. And yeah, that's my game. There was a demo video on the bottom. So yeah, so this just shows off some code. This, I just ran a debug to make sure that all the code is running correctly. And I'm entering in my username, as well as the time I want to give myself to ensure that I can get the highest score possible. Yeah, you can see here I've first guessed the word slate. The word letter S is highlighted yellow, which means that it is in the word. However, it is not in the correct position. So I just did a third guess. The letter O is highlighted. So you can see here that the letters O and I are highlighted green to ensure that, say that, oh, I'm in the correct position. So yeah, that's my game. And yeah, that's all.
Hi guys, my name is Jay. I'm here to show you my disaster simulator game. This game was created with the Unity engine software that allows you to create like management games with different assets and designs. As you can see here, I'm using like the polygraph design, using like the blocky shapes. And in this game, players are placed in a natural disaster setting. There's multiple levels such as forest fires, earthquakes, and tsunamis, and they have to navigate through the entire terrain with an item and reach the end portal to survive. And then they can use main controls like WASD to move around and jump with space. And then they have an item functionality where they can press E to be able to use like a medkit, flashlight, or fire hydrant. So today I'll be showing you a tiny snippet of it with the fire mechanic in, sorry, one of the levels. It simulates an accurate scenario where the fires are spreading to the flammable objects and or disasters such as earthquakes that cause buildings to fracture. If you go back to the previous slide, it shows a forest fire where there's a particle effect. To create a realistic fire, I had to use a particle system that emits multiple particles. And I had to adjust the particle settings to distribute the particles and change the gradient of the color. Each particle system has a hitbox where if the player collides with it, they can take damage and lose a bit of health. This image shows the fire spreading through the forest with the particle system showing a gradient of yellow, orange, and red. For the actual game mechanics, I needed to simulate a fire by making it spread outwards. This code segment first takes a random tree. As you can see here, the tree array bracket rand. This takes a random index in the tree. So it can start at any point. From there, it goes through a for loop that iterates through the entire list, basically, of trees to check the distance from the initial flammable tree to all the other trees. This is so it can spread accurately from the closest trees to the furthest, like a real fire. And you can see it uses a key value pair. This is the element that links tree with the distance. So whenever it calls upon the tree, it'll show the distance as well. And then you can see here in the last statement, it sorts through the entire array, so the fire begins at the closest tree and spreads outward. And here's a video that shows this process. You can see here it starts in the bottom right and it spreads outwards. It can be, I added the delay to be able to control how fast it spreads. So if you shorten the delay, it'll go faster, and lengthen it, it'll start slow. And yeah, that's it. This is the fire mechanic. There are other mechanics, but this is the probably the most complicated one, where the players have to traverse through it in order to survive.
Hi, I'm Cecilia, and this is my gene crafter game that I made on code.org. So I made this game, and it's like used to simulate how scientists insert genes into bacteria in real life. So this is like the start screen, and then when you click the drop down, there's three genes that you can choose from: the RFP, the antibiotic resistance, and insulin. And once the player clicks go, the game simulates transforming 5 bacteria by running through 3 steps, which is uptake, replication, and expression. And then each step has a 20% chance of failure. So you can see in my code that I use a random number generator, and if the number that is generated is less than or equal to 2, then it'll fail. And if at least 3 out of 5 bacteria complete all 3 steps, then the transformation is a success. And if there's fewer than 3 successes, then the player will see a fail screen. So at the bottom, from on the very left side, you can see the fail screen, and then the next 3 are what you would see if your transformation succeeds, and uh there's a screen for each gene: the RFP, the antibiotics, and the insulin.
All right, hi guys. My name's Kevin. I'm a rising junior at Troy, and I'm the director of engineering. And the game I made is very similar to Zach. It's called Wordle Bot, which is basically just the Wordle that we all know from New York Times. So basically, the gameplay is very simple. It's a lot like the game Wordle because it kind of is. So basically, you're giving 6 attempts to guess a 5-letter word, and the green represents that you got the right letter in the right spot. Yellow, correct letter but in the wrong spot, and gray, it's the incorrect letter. But my game also indicates invalid attempts. As you will see in the video at the beginning, I will type a 6-letter word, and then it'll show how the attempt is invalid. So if we could get the video. Yep, as you can see there, I typed a 6-letter word and I said invalid input. And I tried solving for the Wordle right here. And I end up getting it, and yeah, it says congratulations, you got it. But if you don't get the word, it'll like return after 6 attempts, whoops, you didn't get it, and then it'll tell you the actual word. So Python code is actually it's only like backend. There's no GUI, there's no graphic user interface, and it was coded on replit.com. It was like more logic focused, I say. This game was more of like a test of whether like I can code or not. So it was sort of like a test your knowledge type of game. So I basically implemented like basic for loops, while loops, and checking indexes. So I think this would be like a great mini project for you guys to work on if you guys are interested. So I also built it this way because it was easy to test and debug, which is true because it's very short. And yeah, I was able to focus on the core programming concepts, and it's actually very easy to share and run on any IDE. So if you scan the QR code, it'll actually take you to the Replit project, and if you go there, you'll see the code. If you're interested, you can take a look at that. And a challenge that I ran into was trying to make like if the secret word was apple and my guess was alarm, how would I make the second A gray and the first one green? So basically what I did was actually you can see on the bottom right there that little snippet. I basically counted how many times a unique letter from your guess appeared in the actual secret word. And basically every time there was one, like there was one match, it would turn it either gray or yellow or green, and then it would minus one from the total count. And then so that one A is used up, and the second A has no remaining like matching A in the secret word. And that's how I basically went around that problem and solved it.
Hi, I'm Isabel, and I'll be talking about the game of life. So, a little bit of history. So, this is a game that was invented by John Conway, which was a Cambridge mathematician, and it was invented in 1970. And what's unique about it is it's a zero-player game, so there's no active players. And essentially, the cells live or die based on some simple mathematical rules, and it shows how complex patterns form from simple interactions. So there are four simple rules. The first rule is underpopulation, which means any live cell with less than two live neighbors dies. The second rule is survival, so any live cell with two or three neighbors lives on to the next generation. The third rule is overpopulation, so any live cell with more than three live neighbors dies. And the fourth rule is reproduction, so any dead cell with exactly three live neighbors becomes a live cell. So if you look in the photo on the fourth column, you can see that in the end, the cell um, is underpopulated, so there's less than two live neighbors, so then that leads to death. So some common patterns in this game. So still lives means that there's like stable patterns that don't change from from generation to generation. So for example, if you had a block, there would be four blocks and each cell would always have three live cells as its neighbors, so it would constantly live on. And oscillators, which means patterns return to their initial state after a certain number of generations. So this causes repeated cycles. And then spaceships, which are patterns that translate themselves across the grid so they move from one place to another over time. So the game of life is usually created with a 2D array where each cell is either alive or dead. So you can see kind of an example on Python. And you can try the game of life on these websites that are listed below. And you can also see some of the programming libraries you can use to recreate this game.
I'm Kaden, and this is my word guessing game. I made this in code.org with JavaScript during CSP. You're supposed to play this with a friend on the same device, and it's a very simple game. And I just have some images to show you how the game works. There's some UI where you input a letter and then you wait for the other player to input their letter. And when you think you have enough information, you can use the lower box to guess the word. And if it's correct, it'll say that you're the winner, just like in the last image. And this is just a very simple game that anyone could make. And yeah, that's about all these games.
Okay, so my game is called Dessert Clash, and it's also a pretty basic and fundamental game because I created this in my computer systems class. So I built this dessert themed app using code.org's app lab and then with JavaScript obviously. And so it has a login system where users can create accounts and securely log in with their information saved on the code.org's built-in user data tables. And so once you're logged in, the users can see a clean, easy to use main menu where they can pick from four different mini games. And so each minigame has its own unique gameplay style. So there's something fun for everyone. So as I mentioned, it saves the user data table with usernames and the IDs in the user data tables. So the player's progress and preferences are stored securely and can be accessed across sessions. And so there's also a records page which keeps track of the highest record for select games. And so my code also follows a modular structure in which I worked on each separate minigame by itself first, and then I combine everything together with the login page as well as the other elements. And then so I use event listeners and conditional statements to respond to what the user does, like clicking buttons or entering text. And so timers were also built with JavaScript set timeout and set interval to help me create countdowns for the timed games. And then I also use randomization throughout the app to keep things, going and the game working. So whether it's like picking story elements for the Mad Libs or the shuffling quiz questions. And so, as I mentioned before, the game includes 4 mini games, and the first one is about movement. So it's a timed clicking challenge where players try to collect cake toppings that bounce around on the screen. So it's comparable to Fruit Ninja. And so I programmed the objects to move smoothly using timers and updated their positions randomly to keep the challenge dynamic. And so the game also tracks the time left with the countdown timer, and then when the time runs out, the final cake visual and the record score is shown. And so Mad Libs is a creative story building game where players fill in blanks with their own words. So users input a word based on the description, so like a noun, an adjective, or number, etc., to complete a funny and unique dessert themed story. So each time you play, it's going to be a different story, and it's a simple text-based game, but it's fun to see like the different combinations you can get. And so the third one is a cake recommender. So players will input their budget and their favorite cake flavor. And based on that, the app filters through a list of cake shops and suggests one for you. And so this game involves form inputs and conditional logic that narrows down the suggestions, providing a personalized list of places where you can go get cake based on your specific inputs. And so the last one is the dessert quiz. So this one's pretty self-explanatory. It's a quiz challenge that players can play with multiple choice questions about desserts, and then each question is timed. And at the end, the player can see their score and also find the leaderboard and who has the highest record.
Hello, I'm Derrick, and my project is Grow a Garden. So this is Grow a Garden, a browser-based farming simulation game that I built using HTML, CSS, and JavaScript. The idea was to create a casual and rewarding experience where the players would be able to like plant seeds, water them, and watch them grow over time, and eventually harvest them for in-game currency called shekels. This was inspired by other farming games like Grow a Garden on Roblox and Stardew Valley. And I wanted the game to be fun, visual, and interactive. The game has different plant types with their own growth times and harvest values. Some even have mutations. For example, you might grow a normal tomato, but with luck, you might get a cherry tomato for a bigger reward. The interface works on desktop and mobile, and the whole garden updates in real time. If you want to check out the code along the way, I'll send you guys the link. And you'll be able to remix the app and make your own changes and run it yourself. Next slide. So the behind the scenes, the core game logic lives inside a file called gardenengine.js. This is where the magic happens, planting, watering, harvesting, and all the timing and progression systems. Each plot of land on the grid tracks its own state, like what plant is growing there, how long it's been growing, and whether it's been watered. The growth is updated every second, and the plant progresses through stages from like seed, sprout, growing, mature, and ready. And the current weather, which changes over time, also affects how fast they grow and how valuable the fruit is. Players will be able to spend shekels to maybe unlock more plots and sometimes get special plant mutations like popcorn from the corn or giant sunflowers and buy seeds from the seed shop. The entire system is modular and event-based, so I could easily expand it later with new plants or different mechanics. So yeah, UI and visuals. One of the parts that I had the most fun with is the UI and visuals. I wanted the game to feel alive, not just like numbers, but with actual animations, feedback. And the UI is handled by the file ui.js, which gives the player real-time updates. For example, when you plant a seed, the game shows a floating message and plays a sound and triggers a particle's animation. The visuals.js file uses canvas rendering to draw each plot, plant stage, and weather effect like rain or sunshine. And the visuals bounce slightly to give that cartoony and playful feel. I also used a separate weather system to create changing moods and particle effects like droplets or sparkles when a plant is harvested. These small touches make the game feel very reactive and help players feel more connected to the garden. Next slide. Oh, so finally, one of the biggest features that I added was multiplayer support using socket.io. This allows players to connect and interact in the same garden world. You can see their actions live in the UI, whether when someone plants or harvests, and it would show up for you too. There are also community actions like watering all plants at once or triggering fertilization boosts. Adding multiplayer taught me more about real-time communication, sync shared states, and handling multiple users. More broadly, though, I learned about a modular project from scratch, splitting the logic, visuals, and UI across several different files, and also practice animation, CSS styling, and some game balancing to make the plant economy feel more rewarding to you guys as a player. Overall, this project would help you and also help me grow my programming skills and the ability to design fun games. Thank you.
Great. So I think all the presenters for today's webinar presented. All of you guys have super interesting projects, and if any of you want to follow along with any of the projects, so some of us have shared links in the chat. If you guys want to remix those and then kind of look through the code on your own, that would be awesome. And maybe if you come up with a new creation on your own that's based off of the original one, feel free to email us with your new creation, and yeah, you can show your code as well. But yeah, that's all for today's fun coding session. Thank you all for attending. Once again, if you have any questions or concerns, comments, feel free to email us, and also feel free to check out our website as well. All right. Thank you guys.